Hello students and welcome to this video. In this video, you're going to learn about the mean value theorem. So let's get started. So remember from our last video where we were going over Rolle's theorem? Well, Rolle's theorem guarantees that if a function is continuous on that closed interval and it's differentiable on the open interval, and we know that f of a is equivalent to f of b, then there's a guaranteed value where the instantaneous rate of change is equal to 0, where f prime of c equals 0. So the mean value theorem is actually very similar. And Rolle's theorem is a specific case of the mean value theorem. And so what we want to do here is let's go ahead and state what the mean value theorem is. So what we're going to do is if f of x is continuous on a to b and it's differentiable on a to b, then there is a guaranteed value to exist on a to b such that f prime of c equals f of a minus f of b over a minus b. So what that means essentially is that if you find a secant line between 2 points, there's a guaranteed value, as long as it's continuous and differentiable, in between those 2 points where the derivative is equal to that secant line, that average rate of change. And so what we want to do here is we're going to take this idea, this mean value theorem, and we're going to start applying it to this function in this video. So let's consider this function h of x where it's 3 minus 5 on x. And so we have the graph over there on the left side. But first we want to realize, does the mean value theorem apply on the interval from -1 to 5? Well, since h of x is undefined at x equals 0, because you can't divide by 0 right there, therefore the mean value theorem can't be applied on this interval from -1 to 5 because 0 falls in between that. So it's very important to remember that the function needs to be continuous and differentiable over that entire interval. So now let's look at this next question. Does the mean value theorem apply on the interval from 1 to 5? Well, from 1 to 5 here, we can see that it is continuous the entire time. And since it's curved, that's going to mean it is differentiable. So therefore, the mean value theorem can get applied in that case. So what does the mean value theorem guarantee for the function on the interval from 1 to 5? And so we want to draw this on the graph. So really what we want to do is let's connect the points from 1 to 5, all right? Something like that. And so what we're guaranteed is that somewhere in between here is a tangent line where it is going to be parallel to that secant line. And you can kind of see it here. If I kind of draw a tangent line almost at x equals 2, you can see, maybe if my hand was a little bit better or my sketch was a little bit better, you can see that the secant line is parallel to that tangent line that I just drew there in red. So still, it's very important to note that the two y values don't need to be equivalent like they had to be in Rolle's theorem. They only just need to follow those first two conditions of being continuous and differentiable. And so now let's apply the mean value theorem to find the value where c is going to be guaranteed for h of x on this interval. So let's start by finding the derivative. All right, so let's see, h of x, and I'm going to rewrite it. It's going to be 3 minus 5x to the -1st. And so h prime of x is going to be 5x to the -2nd power. All right, so let's kind of rewrite this here. So we're going to get 5 over x squared. Well, now we also need to find that secant line, the slope of the secant line. So f of a minus f of b over a minus b. So we're using 1 and 5. So f of 1 minus f of 5 is over 1 minus 5. And then that's going to be -2 minus 2 over -4, which comes out to be +1. So we need to figure out when is 5 over x squared going to equal 1. So let's solve for this. So I'm going to get 5 equals x squared and then take that square root of both sides. And we're going to get the positive and negative square root of 5 gets us x, or the c value that is guaranteed. So, well, which one of those again falls in the interval that we're looking for? So The negative is 2 negatives. So the positive, the square root of 5 is about 2 point something, and that falls within the interval from 1 to 5. So C must be the positive square root of 5. And you can look at the sketch above where it looks like it's just after 2, where that tangent line is parallel to the secant line. And so you can make those connections now as you're making the comparisons between the graph and the analysis that we're doing here. So this is going to be a quick example in this video, and in the next video we're going to go over a couple more problems applying the mean value theorem. If you need any help in this video, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.